Hello everyone, welcome back. I hope everyone is doing great. Let's solve an interesting problem today. Next greater element. Okay, problem statement states you are given an array ARR of integers. The task is to find the next greatest element for each element of the array in order of their appearance in the array. The next greatest element of an element in an array is the nearest element on the right, which is greater than the current element. Okay, if there does not exist next greater of the current element, then the next greater element for the current element is minus 1. Let us look at this particular example, okay, which is already given in the input. Okay, if you see there are no elements next to 4, so the next greatest element for 4 will be minus 1 as stated in the problem. Okay, for 2, if you see the next greatest element is 4, so answer to 4 is 2 is basically 4. If you see for 3, 2 is not greater than 3, so I will skip, this is not my answer, and I will go to 4. 4 is actually greater than 3, then the next greatest element for 3 is actually 4. Okay, that is why here we have 4. Coming to 1, 1 3 is actually greater than 1, so the next greatest element for 1 is 3. Okay, so if you see, this is one of the approach how we can actually get this. Okay, the brute force approach will be straight away for each element iterate to the rest of the elements, and the moment you encounter an element which is greater than the current element, then that will be my potential answer. For 1, 3 is greater, okay, which is nearest and the greatest. Again for 3, 4 is the answer. For 2, again 4 is the answer, and so on and so forth. Okay, so if you see, while I was explaining, right, I have basically traversed from left to right. Okay, so at any given point, okay, if you traverse from right to left to right, then the question states the greatest element, next greatest element on the right, right? If you traverse from left to right, you don't know what numbers are coming on its right side. Okay, so intuitively it's better to traverse from right to left. Okay, so by default there are no elements to the last one, so answer to the last will be minus 1. Okay, I'm just taking the first example to explain you the intuition behind it. Okay, so the next greatest element for 9 is minus 1, right? So this is done. Now when I'm looking at 4, for 4, 9 is the next greatest element, right? I have processed for 9. I know there are no greater elements to its right, but 9 can potentially be answer to my all the elements on the left. So I will be storing 9 separately, saying that 9 can be potentially my one of answer, right? Now I am at 4. Now I will check 4, is it actually lesser than 9? Yes, it is, right? So for 4, 9 is the next greatest element, so I will place 9 here. And 4 can actually 4 can potentially be a next greatest element for any of these numbers, right? So I will be placing 4 also, right, in my search space. Okay, now I am at 8. Is 8 greater than 4? No, right? So 4 can not be a potential answer for me, so I will remove 4. Okay, I will remove 4. Now I will compare 8 with 9. Is 8 lesser than 9? Yes, it is. So for 8, the next greatest element is 9, so I will be storing 9 over here. Now again, 8 is a potential greatest element for all the elements before to it, so I will be storing 8 separately, saying that it can be potential answer. For 2, I will again check here. At any given point, if you have noticed, I was first checking for the elements which are recently processed, right? When I was checking for 8, I was checking for 4 first, right? So at any given point, I was looking for recently processed elements, right? So which data structure will help me to retrieve the recently processed? If you see stack, right? If you visualize these elements in a stack will always help us to retrieve the elements which are recently processed. So if I push eight to into a stack, then again I can get eight only. I cannot get 9 because 8 is the one which was recently processed into the stack, right? Now if you look at 2, I will compare 2 with the recently processed one which is on the top of the stack. Yes, 2 is less than 8. So for 2, the nearest greatest element will be 8. Okay. Now again 2 can also be a potential answer for me. So again I will push 2 into my stack, right? So I am at 3 now, right? I am at 3. I will compare 3 with my recently processed 2. 2 is not greater than 3, so I will remove 2 from my stack. Okay. Now is 3 greater than less than 8, right? 3 is less than 8, that means 8 is the next greatest element, right? So I will be having 8 over here. Again 3 can potentially a greatest element for elements which are before to it, so I will be pushing it into stack, right? After processing every element, if you notice I am pushing the current element into the stack, right? So that it can be potentially a greater element for the elements which are before to it. Okay. Now I am at 7. Is 7 greater than the element on the top? Yes. So 3 is not a potential answer, right? I was looking for an element which is greater. Okay. Is 8 greater than 7? Yes, 8 is greater than 7. So 8 can potentially be answer. Okay. So if you keenly observe, I was processing the elements from right to left, and I am using a data structure which is stack in order to retrieve the elements which were recently processed. Okay. Let me take one more example and explain you so that it will be lot more clear. Let's take 1 3 2 4. Okay. As I mentioned, I need a data structure which will help me to retrieve the recently processed elements. Okay. For 4, there are no elements on its left, so by default I will push 4 into my stack and I will have -1. Okay. Now when I'm at 2, is 2 lesser than the recently processed element? So the recently processed element will be on top of my stack, right? And is 2 less than the element which is on the top of my stack? Yes, it is less. That means the element on the top of the stack is basically the next greatest element for 2. Okay, so I will be having 4 over here, and 2 can be potential greater element for elements which are before to it, so I will be pushing 2 into my stack. Okay. Now I am at 3. Is 3 lesser than the element in the stack? No, it is not. That means 2 cannot be the next greatest element for 3, so I will be removing 2 from my stack. Again, is 4 greater than 3? Yes, it is, right? 4 is greater than 3. That means 4 can be the next greatest element for 3. Yes, it is, as you can see from here. Now 3 is already processed. Now I will be pushing 3 into my stack. Now I am at 1. Again I will check whether the element in the stack, the top element in the stack, is it greater than the current element? Yes, it is. That means it is potentially my next greatest element. Again, since 1 is processed, I will push 1 into my stack. If you see, this is what the final state of the stack is, and these are the next greatest elements for all the elements for the given array. Okay, I hope you got the intuition. The idea is to traverse from right to left and then keep track of the recently processed elements in a stack. And if you see, the stack is actually growing in a specific manner. Okay, at any given point, stack is containing elements in the decreasing order. Okay, if you see from bottom to top, the elements are in the decreasing order. So this is basically a monotonic decreasing stack. Okay, since the reason being the elements in the stack are decreasing from bottom to top. Okay, so let's jump to the code and see how we can implement this. Okay, as I mentioned, we'll be using a stack, right? So if you see, the return type of the function is basically array of integers. That means we have to construct an array list which is of same size of the input array. So I've defined a variable n which is of size of the input array, and I just defined the next largest element array list with the size n, and I populated all of them with -1. You can also do this with standard for loop, but this is cleaner way to do it. Okay, now we have stack. Okay, we as I mentioned, we'll be using a stack data structure, and we'll be traversing from right to left. We'll be traversing from right to left, and if the stack is non-empty, right? If the stack is, if you see, if the stack is non-empty, and if the topmost element in the stack, if it is greater than the current element which we are processing, that means it is potentially a next greatest element for the element which we are processing, right? So as long as my stack is not empty, and if the top element, okay, and if the top element, if it is less than the current element, that means it is not a potential answer from me, right? If it is greater, then that is a potential answer, right? But if it is less than or equal to the current element which I am processing, if you see, let's say we are at 3, but stack contains 2 and 4. Okay, now the top of the stack is less than or equal to the current element, so I have to pop 2 from it, right? So we will be popping the 2 from it. Now the stack will contain 4 as its top element, and 4 is not less than or equal to 3. That means this while loop will be breaking, and since the stack is non-empty, the next greatest element for 3 will be 4. So that is what I am setting over here, right? We are taking the topmost element and getting the corresponding value, and we are setting it. Okay, and if you notice, I'm storing the indices in the stack. Okay, it's not the consolidated value, but we are storing the indices. Okay, and once we have processed the current element, okay, again we have to, this can potentially be a next greatest element for the values in before to it. So I will be posting into the stack. Okay, and in the end I will be returning next largest element ka array list. Okay, if you submit this, all the test cases will be passed, and it will be pretty efficient solution as well. Okay, that's all about this problem. If you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. There is also a different way to do this problem. Okay, this is more intuitive, but here if you see, we are processing the elements from right to left, but there is also a way while we are processing the elements from left to right, but still we can able to achieve the next greatest elements. Okay, I will create a separate video for it, and I will be uploading it. Stay tuned for the video. Thank you.